So for the background, so I work in the M3 team, which is Uber's metric system. It provides the end-to-end functionalities for metrics. We collect metrics from every box in the data center, and then we aggregate metrics, we store them, we index them, and we provide query service on top of the data storages. And originally, all the metrics were stored in Cassandra, and then we find a lot of operation issues and inefficiencies with running lots of huge, large Cassandra clusters. That's why we started building this database called M3DB in 2016, which is an in-memory time series database, and it's optimized for time series data. So it uses a compaction algorithm called like delta over delta, which is published by a Facebook paper. And we use that compaction algorithm at least M3DB's core and basically build this in-memory database on top of it. And it provides like really efficient compaction over time series data. And we want to make this M3DB open source offering. So we needed open source library for runtime configuration management and then cluster management for the database as well. So let's talk about the architecture of M3. So this is how it looks like. So we have collector running on every box in Uber's data centers that collects the hardware metrics and service metrics that runs on that box, and then all the metrics are being flushed to an aggregator tier, which aggregates metrics into different dynamic resolution, retention, aggregation types, basically apply all kinds of different policies. And then they will be flushed to the ingester to write to all the data storages. We isolate the storage by their like retention use cases. So basically short-term stores data with shorter retention, and Glacier stores like data with like years or unlimited retention. And then we have an indexer, which stores the data in index. And then we have some legacy ingester that still writes data to Cassandra and HDFS. And then we provide a query service on top of our storages. So where is etcd in this architecture? So basically, it's like being used everywhere. It's exposed through this M3 cluster interface we built, and then it's been listened by all the collectors and then all the boxes on the ingestion pipeline. And as you can imagine, we have a huge amount of etcd clients and watches built on those etcd clusters. So just give some numbers. For the collectors, we have about between 20 to 30,000 box within each zone. So the etcd cluster need to support all the watches from all those clients. So more about M3 cluster. So it's basically a library built on top of etcd client, and it provides heartbeating functions. For example, the service participating in the instance participating in the service will keep heartbeating its information, and that information could be used for automatically fix topologies and stuff. And then we build leader election on top of etcd's concurrency package. We built M3KV, which is a key value interface based on etcd key value interface. And then we provided our own service discovery semantic on top of the M3KV interface. And then for M3KV, it provides the common APIs we need, like get, set, watch, and then check and set and transactions. Those are very important when it comes to topology changes. And besides, those are mostly provided by etcd. We're just like building on top of it, and then we just added this on-disk value cache so that the KV like clients can like start up and with the last known value, even though etcd is down. So before we choose etcd, we actually evaluated quite a lot of different options, including Zookeeper, etcd, and Console. But eventually we went with etcd. So all of the Uber's metric system, everything in M3 is written in Go. And since we want it open sourced, etcd fits perfectly. And they had a very active community on it. Like a lot of our issues are being responded and answered like quickly by the maintainers. We're really happy with that. And then also it's battle tested in production. The Kubernetes gave us a lot of confidence in choosing etcd. Also, it turns out to be super easy to operate. While we were load testing etcd, it's very easy to set up a cluster, play around with it, change stuff. Everything is just very smooth. Also, the performance of the reads and writes is way better than Console, also comparable to Zookeeper. We are very happy with the use case. What we cared more about is the watch use case. It's a very critical use case for M3. As you can see, we have tons of watches on top of etcd cluster. So we did a lot of like thorough load test for this watch use cases. So this test was done back in 2016 or early 2017. So we set up like a 3-node etcd cluster, each box with 24 cores, CPUs, and then 128 gig RAM with SSD. So we mimicked 30,000 clients from 10 similar box, and we created 4,000 watches per client. This is way more than what our production load looks like, but we just want to load test it a little bit over the production traffic. And then we created one watch, one update per watch, per key, basically. And then the payload is not too big. So in this test case, we had like 120 million watches, and we send out 120 million updates. The latency distribution, as you can see here, is pretty nice. We are very happy with the result. And the load on all the box looked super very nice to us. The load and memory was under no stress at all, and the number of watches were evenly distributed among the boxes. There are no slow watches, and also we're happy with that, with the fact that watches are reusing and sharing streams. So we tried a lot of other tests, and then let's say, for example, this one we increased the payload for each value, and then it's a lot more data to push out, but then still the latency is very acceptable to us. Also, even for this case, the performance on those boxes looked very reasonable. We did some other tests as well. For example, even increased the payload to 1.5 megabytes, and then we realized that the only bottleneck was on network out from the etcd cluster. The load and memory are still very reasonable, and the cluster is functioning just fine. We just need, I think that can easily be solved by adding more nodes to the cluster or using proxies. So we are very happy with etcd. So on the operations side, we use compaction and backup natively supported by etcd. And then, but besides that, we added some own logic within M3 cluster. For example, we manage multiple clusters, mainly for isolation purposes. So we separate clusters by availability zone, and also like use cases. For example, we have a cluster that contains that provides accessibility to external users. So we want to separate that cluster in case the user some bad user behavior happen on the cluster, and then bring that down. And then we have other clusters that were separated for different use cases as well. And all of those are managed by M3 cluster. So whenever we look up a key, you provide a zone, a namespace, an environment, and then the M3 cluster will be able to look up which etcd cluster should route this request to, and then perform the read or write to that cluster. Yeah, that's pretty much how we use etcd in M3. We've been using it for over a year, over a year now. We've been very happy with it. I want to thank you guys for making such a great product.
Yeah.
Yep.
No, Friday works.
Is there any questions for me?
Hey, Chao, I have one question.
Mm-hmm.
You said you evaluate Zookeeper and XCD at the very beginning, right?
Mm-hmm.
I'm curious how you are using the XCD. You just using the XCD client to do all the operations. From your chart, I think there's some leader election. Those are the best practice. I'm just curious, how do you adopt the leader election practice? Because for Zookeeper, it has some recipes, right? You can, it has recipe, it has leader election, it has cache, you can use that. But for XCD, I'm not sure the native client can provide that functionality.
The leader election, no, it's provided by etcd.
I'm not just for a leader election.
Like what?
For example, let me see. So it has quite a lot of the recipes. For example, leader election is the most popular one, and also some cache. You can cache some data into the client. You can specify the directory or the path. And also, I think there's some log you can use, some shared log.
So you mean those are provided by Zookeeper?
Yeah, those are not natively provided by Zookeeper. They are provided by
recipes.
Recipes. Yeah, I'm curious about for XCD how the experience is like.
Yeah, we never really needed those extra functionalities. The core leadership semantic provided by etcd is sufficient for our use cases.
I see.
So, and to be honest with you, like when we started to build our M3 cluster on top of etcd, we didn't actually have the use case for leader election. So we only had the use cases for key value, topology management, heartbeating, which are all sufficiently provided by etcd. We're just happy that when we discovered the use case for leader election, etcd was able to support it really well for our use case.
Yeah. Okay, sounds good.
Hi, so I'm Xiang from Chorus. So actually in etcd, we have a client package called concurrency.
Yeah, that's exactly what we built on top of.
Oh, I see.
Yeah, so basically we in our library, so I think the library provided by etcd is a very generic one. I think it's in order to handle all sorts of like edge cases, so it exposes a lot of information to the user. But so for us, we have a very limited range of use cases. So our library basically wrapped a lot of the error handling, status handling, and then exposed the less status to the user of our library. So it makes the application much easier to use it.
Yeah, that's exactly what I'm talking about. Like usually we have some wrapper to handle all the errors, and it can do some automatic retry or stuff. So yeah, I was very curious, like this wrapper, you guys want to open source it?
Yeah, maybe you can check out. So I think the M3 cluster is actually available on GitHub. I mean, I'm very sorry that it doesn't have very sufficient documents because it's mainly used internally right now. But as part of the effort to make M3DB an open source offering, we probably will definitely invest in documenting most of the stuff better, so to make sure people can use them, reuse them easily. So for M3DBs, we are right now targeting to be. So I think in the like metrics world, many people are using Prometheus right now, and we're trying to make M3DB. Actually, we're working with Prometheus to trying to make etcd a remote clustered storage for it, because as you know, Prometheus is all single noded. It doesn't provide like replication and all that stuff. So, but M3DB handles all that, because like from day one, we are targeted to build a huge replicated database to replace Cassandra. So all of those things are already provided by MCDB. So right now we're trying to bridge the gap between Prometheus and MCDB, so users can start to use us as their clustered metrics storage. So as part of that effort, we'll probably try to improve the documenting a lot in some of the dependencies, including MC cluster.
Thank you.
Yeah.
Hey, Chao, I have one more question. What's the data size of SCD cluster?
The data size, right. So right now, I think for us, I can double check. I think we only have hundreds of megabytes. We don't, but we actually in the beginning we measured in the worst case we may need let's say quite a few gigabytes, maybe in 50 or almost 100 gigabytes. So we were worried about the limit on database size might be an issue for etcd, but we've been talking to Sean, and I think we are able to lose that constraint through a config. So we probably will use that when the day comes. But so far, we only have about maybe 1 or 2 gigabytes of data in the cluster.
And how do you guys like handle upgrades to
etcd version upgrades?
Yeah.
Yeah, I think our SRE are more familiar with that. So in our team, we have an SRE that's more familiar with those setups. So we basically run etcd, config etcd using Puppet. Yeah, how do we handle upgrades? I'm not exactly super sure about it, but from his experience, I think he's been fairly happy with the use etcd to upgrade. But I think recently, since he's trying to upgrade to 3.3, he mentioned there's like a breaking config change. Is that true? Like, how do you config compaction? It used to be, I don't know, like.
Oh yeah, you can make it more fine-grained in 3.3.
Yeah, right. I think, but then that changes, that breaks the old format or something. I don't know. That's
no,
what
it's compatible. It should not break anything.
Okay. All right. Yeah. Yeah, for that, I don't have too much deep knowledge into it because it's mainly being handled by him. I can probably invite him to the meeting next time if you guys want to hear more from him.
Yeah, that would be great.
Cool.
If you don't mind, I have one quick question. I don't know if you know the answer to this, but you mentioned storage size was something you were interested in. Do you have any sense of like how many objects that might correspond with as well?
How many objects? You mean how many keys?
Yeah, how many keys?
Yeah, so we were talking at just a few thousands of keys, but or maybe more. But every key could be big in terms. So we are right now the limit is on 1.5 megabytes per key, I guess. But we could be using more. But if etcd is not going to support larger keys, we could potentially like have our own wrapper, our own logic to separate large keys into multiple smaller keys just to work around it.
Yeah, so
that's our plan for now. But it would be great if etcd can just allow us to store like larger payloads per key.
Yeah, so you're more interested in large amounts of data, but not particularly huge key sets.
Yeah, we don't have huge key sets so far, but I don't know about the future. But right now we don't. We just have a reasonable amount of keys. Some of them may have large payload, but we have lots of like watches on those keys.
Okay, thanks. That's good to know.
Yeah. Cool.
Okay, thanks, Charles.
All right, thank you, guys.
Does anybody want to discuss any discussion topics?
I just had one quick question. Thanks, Xiang, for talking about the concurrent reads. I was curious. I know that Bolt has the concurrent read support, which would be great to take advantage of. I also know that there's a kind of a additional MVCC layer at the key index within etcd. How concurrent could that be made? Have you thought too much about that, or what it limits?
problem that
Sorry, I think we lost audio there.
hello?
Okay.
Hello?
Yeah, I can hear you now.
Okay. So basically, in front of the bolt write transaction, we add another layer because bolt is basically a B plus tree. So if you use the row bolt transaction, one write will trigger several disk I/O operation. So we have another write back cache in front of bolt DB, but that write back cache actually made concurrent read a lot more difficult, because read also needs to go into that read buffer to get the current read value.
That makes sense. Okay.
So what I'm doing right now is for some reads, it can actually wait there and wait for the write buffer to be committed to disk and then start to read from the disk.
Yeah, that sounds okay. That makes sense. So that's the first thing we would focus on. And then if that got cleared, we could then look at the other aspects.
Yeah, so for Kubernetes use case, for the controller managers, restart is usually issue a very large reads, right? For that large reads, doesn't really care about how long it will take, right? It would just care about okay, this should be run concurrently with any writes, right? So what we are doing here is waiting for the write buffer to flush out to disk and then start the large read transaction concurrently with the current write.
Right. Yeah, this actually be a huge help for Kubernetes restarts where the watchers all get reset.
Mm-hmm. Okay.
Thanks.
Anything else?
You need to use your mic.